Excellent. Good morning, ladies and gentlemen. If you're having trouble hearing me, that's what these are for, okay? So this helps you hear this particular room if you haven't been in the hub before. So please put these on your ear and then you'll be able to hear me and our speakers much better. My name is Dr. Deborah Elms. I am Head of Trade Policy at the Heinrich Foundation in Singapore, and it's my pleasure to welcome all of you this morning to a session on semiconductors. Where will they land? And as all of you know, there are many reasons why we suddenly care a lot more about this question than we used to, not the least of which is the growth of the semiconductor sector, the possibilities of continued explosive growth in the semiconductor sector, the amount of money that's being invested, especially in the form of subsidies, and the areas in which semiconductors are primarily used are increasingly strategic. So it's about automobiles, it's about cloud computing, artificial intelligence. Those are themselves viewed as sensitive sectors. And so there's a lot more interest now in semiconductors and in the location of semiconductor production than we've ever seen before, or at least in recent memory. And so I think that's a very timely reason for holding this session here. We have two fantastic speakers, one of whom has got a microphone issue, so I'm going to stall for one more second, from Stanford University, and followed by the trade minister out of Malaysia. So I'm really delighted that they have both agreed to come and speak. In this hub area is a very short, intensive agenda. So we have 28 minutes left. I'm going to prompt you now because when they finish giving some opening remarks, we will be able to open it up for questions and answers. So start thinking already about what kinds of information you would like to receive from our two experts today and prepare for those questions. So now we appear to be ready. Yes? So with no further ado, let me hand it over to our first speaker out of Stanford. Thank you so much.
I'm good to go that way. You can hear me, right? So, hello everyone. Greetings to the world of semiconductors. My name is Shrubanti Chaudhary. I'm a professor at Stanford University in the electrical engineering. And prior to that, I did have experience with startup. We work with industry a lot. It couldn't be a more exciting time to talk about semiconductors because guess what? The only type of chips that people used to know were probably not made out of semiconductors, but now they do. So everywhere you go, whether it's in your Uber ride or in your, discussing in your couch, today semiconductor chips is a popular household name. So what I'm going to go through in my time that I have, this is a curation that we very recently did, and I kind of gathered around the points and was tremendously helped by the forum leaders here. So I will go through one by one. There's a pretty exciting touch screen, also possible because semiconductors are working, so I'll go start with that. So first of all, I think my favorite topic is sustainability. I'll go there. Okay, there you go. So the word sustainability is of growing importance, and yet no one really understands what it completely means. In other words, everybody has their way of painting this picture, and it is a work in progress, so which is why a lot of these things is unclear right now, and hopefully with time it will get clearer. But one thing that we all know, that it's sort of a chicken and egg problem, and the reason is that if you want a sustainable planet, if you want a sustainable society, you have to be smart, and the way to make things smart is using this tiny little chips called semiconductors, which are made out of semiconductors. So it's kind of helps sustainability. But then the question is growing, that is manufacturing this chip sustainable itself, right? So sometimes you can carve this picture out one way or the other, but it has to be thought holistically, has to be thought hand in hand. And I would argue that at this point in time, it's far more important to make things smarter than impose the question whether manufacturing is sustainable, because the numbers are not yet clear. We still don't know. There is lack of transparency, so to speak, and lack of field data, because only over time we will know whether manufacturing is sustainable or not. So this is important for various reasons, for environment, which is one of our topic, but that we are thinking about a ever warming planet. We're thinking about how to recycle is part of the daily discussion. So where I come from, as I said, I work and I teach at Stanford. I do my research at Stanford. It's where the Silicon Valley was born and brought up, and Stanford played a very big role. We work with industry non-stop to try to understand this, but yet I have to say this is such a complex problem that we haven't yet scratched the surface. I really repeat that. We haven't yet scratched the surface. So a lot of questions are unanswered, and my urge to the community will be having more transparency and global collaboration. Without global collaboration, we will be reinventing the wheel of sustainability, and that is an important topic to keep in mind. I'll go next on the semiconductor science and engineering. I cannot afford to discuss this without kind of talking about the science and engineering. This is sort of the yin and the yang of semiconductor development, and the reason is that without the science, you cannot do the engineering. So investment in research, investment in basic science is a key, because this is probably one of those industries where the science actually pretty quickly get translated into engineering, provided the right structure of investments are made. Sometimes, wearing my professorial hat, we do sometimes a little too stretched out and crazy science, but having said that, if you can envision programs, which we do quite a bit, where you can connect the dots, then engineering leads to the technology, to the implementation much faster than anything the world can ever see, especially in the era of machine learning, era of AI. This is an extremely fast, could become an extremely fast process. So the science and engineering are sort of interdigitated. One will lead to the other. Don't ignore the science is what my humble request would be, because without the basic foundation, nothing can be built strong, and without the engineering, nothing could be built, period. Okay, so it's very important to kind of look into this again in a big picture way. I'm going to touch all the points, and if I have any extra time left with your signal, I will go back to this topic, which is sort of one of my favorite ones. Semiconductor and environment. Well, again, this sort of ties into the sustainability picture. Think about today the amount of renewables that we are all kind of depending on. We have a growing dependency on the renewables. The way energy is converted from one form to another, power is transmitted and converted. Think of anything that doesn't use energy or electricity. Probably none. So that kind of underlines the fact that if you are hooked to the grid, if you're tied to the grid, you must be using something that has to do with semiconductor. This wasn't the picture before. It started with mechanical relays and things like that back in the 60s and 70s and 80s, and slowly we transitioned into the popular material called silicon. So everything we think semiconductor, we kind of assume that is silicon, but that's not true. The LED that is shining bright is not made out of silicon. There are other materials that are catching up and complementing what silicon could do. For example, gallium nitride is one very popular material which makes very bright LED, has changed the lighting industry, actually changed the planet. I mean, think about those places where they have no access to electric grid, but just because of the battery, 6-volt or a 3-volt battery can help light reach those parts of the world where incandescent light could have not glown. Okay, so that is the power of semiconductor. But having said that, what is underlying all that is an increased importance. How do we make things efficient? Efficiency is the key. Even more important, how do we reduce loss? Sometimes efficiency, you would get numbers like 97, 98, 99. It may not mean something because these are all percentage. So you have to think the full picture and think what is the total loss that we could save. And simple way of thinking of loss in semiconductors is wasted energy, right? And if this is one sector where the waste could be recycled, so environment is going to be a major factor how semiconductors will shape up, the biodiversity we are talking about, the climbing temperature that we talk about. So semiconductor and environment are again extremely correlated, and one should be more aware of those as we speak. The supply chain, this is getting into this section of where I think a lot of the audience are worried, and rightly so. We saw a couple of issues very recently. One was the drought in 2021 in Taiwan, where things started to look pretty grim, and one of the issue that we saw was that concentrated efforts in mostly in Asia has led to some of the problems where you had probably heard Volkswagen struggling with lack of chips that runs their automotive and so on and so forth. So the semiconductor supply chain was probably one of the hidden problems that got exposed due to this crisis. There was an earthquake like before, a month before or so in Taiwan. Again, whenever there is a natural disaster or natural or any kind of calamity, supply chain can break. And one of the important part of this equation is how do we decentralize the semiconductor supply equation. And one of the interesting new thing that has happened, you may have heard the CHIPS Act in US. A lot of the Asian foundries are trying to this effort is trying to bring them back in the US, and I think this is just not enough. There has to be many more such efforts so that you can have a much more diversified way of tackling the problem. But as even in an academic lab, I have seen what the semiconductor supply chain problem can be. I mean, at one point we used to put everything as a supply chain issue, and but this is one of those to keep in mind. I'll go quickly, very quickly, to the geopolitics. Without being too political, let's put it this way. The problem is that hopefully, and this is only a hope, the knowledge of semiconductors transcends the borders. That would be one of the sort of asks from a community where I see the cost of reinventing is far too much than the cost of collaboration. This is very important and a key point because the knowledge is everywhere, and we in a semiconductor community follow rules, we write reports, we publish papers, we do patents. So it already has this infrastructure where collaboration is possible only if we don't make it too much of a fighting issue. I'm going to go to the last two very quickly. Educating the workforce, that's one of my job, and I cannot emphasize how important this is. It's empower the younger generation is the key. Today, children, when they do their science and math, they don't understand often that the same underlying principles are also acting in those tiny chips called semiconductors. But what about trying to introduce this as when they're in kindergarten? How about connecting the dots about planet or saving life on a planet with semiconductors early on? Awareness is the key and missing big time. Very important that we rethink how we teach semiconductors. And very important, another point is not everything in semiconductors require a very ivory tower kind of a degree. Okay, it has an umbrella that can be broadened much more than we can think today. I think I want to harp this point that semiconductor is a very inclusive umbrella, and if we do things right, we can only make it grow. And last but not least, semiconductors and the global economy. Well, you are the world's economic leader and you are here, so that already proves that this is kind of showing up its head in the big picture. Semiconductor is kind of propelling advancement much beyond what fuels could do before. So it is advancing the society. Whenever you want to think about pretty sensitive topics like defense, or even our ability to make sure that a nation is thriving economically, the dependency on semiconductor will be growing. So if that's the case, then why not this is the new fuel of the society, right? Fuel of the entire planet. So again, I think the equations are pretty clear. Around in late 2020s, the growth is supposed to or projected to be around about $700 billion, or if not more. And only 10% of that money has been injected to various programs like CHIPS Acts and all. So it's really a small percent. It's still a drop in the bucket. So it's kind of a high time for us to understand that what kind of investment one must make to see a market that is reaching trillion by late 2020s. So with that, I'll give it back.
Standing. Thanks
Thank
so
you.
much. Come on in and have a seat. So now let us take a few minutes to go down to the level of investment, supply chain disruption, workforce development, and look at how one country in particular that might not be top of mind for many of you sitting here has been handling that. And for that, again, I'm delighted to have Trade Minister from Malaysia to give us an insight into what has been happening in Malaysia specifically, where it's actually extremely interesting and very dynamic. So over to you, sir.
Okay, thank you. Thank you, Professor, as well, for the overview of the semiconductor industry. So I'll be giving from the perspective of Malaysia and ASEAN, and to a certain extent Asia as well, from the lenses of a ministry that's in charge of trade, investment, and the industry. So for Malaysia, we have been in the semiconductor industry for the last 50 years. In fact, it is so important and strategic to our economy that 40% of our export of Malaysian total export is from the semiconductor industry, and we have a global market share of around 13%, and therefore we are really very important part of the global supply chain. So I'm going to just focus on the supply chain, the geopolitics, the talent, which is important, the global economy, and also in a way the infrastructure that's required, and going forward, as you mentioned, about sustainability, etc. So first of all, maybe from our view, where Malaysia stands and where we are in Southeast Asia, we have seen the realignment of supply chain, especially in the semiconductor, in a very big way. To give you a sense, in the last 4 years, we've seen semiconductor investment into the region increase by nearly 5 times, right? It is major. And one of it actually started, if we look at it from our data points, it started even just before COVID. In fact, COVID accelerated it. When there were issues about factory closures, because actually semiconductor, if I'm not mistaken, Professor, 90% of the manufacturing of the semiconductor chips is in Asia, right? So when there was factory closures, etc., medical devices, cars, even toys, you stop manufacturing it because the supply chain disrupted. So they were talking about realignment of the supply chain, looking at the resiliency of the supply chain, the security of the supply chain. That people are talking about reshoring, friendshoring, onshoring, because of the risk to the manufacturers. And then come, of course, the geopolitics. The trade tension between two superpowers, various barriers of entry, tariff increase, makes it, the companies especially being, focused on commercial viability, focus on profitability, have to relook at where they are as well. So then come the talk about China plus one. In fact, when we were in Europe, it was Europe plus one, Germany plus one, even US as well, right? So they are diversifying, they are de-risking, ensuring that their supply chain, and I think at the end of the day, it's also about commercial viability, the increase in costs, the increase of energy prices. So they look at region where is the best place for them to then diversify or de-risk their portfolio. So one of the areas, when you talk about geopolitics, that's why we see in ASEAN, Southeast Asia, a nation, a group of 10 countries, economic bloc, of course Singapore is one of them. It is a bloc where focuses on manufacturing as well. They have looked at positioning themselves as a neutral bloc, right? It is a big bloc. It's about the 5th largest economic bloc, population of 680 million people, GDP of $3.7 trillion US dollars. So when people look at that bloc, not just as a neutral bloc, but also as a bloc that they can also expand their markets in, right? It is GDP growth around 4 to 5%. So it is one of the fastest growing economy bloc as well. And being neutral and stable and peaceful also means that it is safe for them to then expand their business out of China or out of Germany or out of Europe or even, but US has been major. US has been a major investor in this area. In fact, for Malaysia, our biggest investors in semiconductor comes from the West, from the United States especially, and Europe. And at the same time, what we are seeing is that for Malaysia, it's been the last 50 years. And even in the region, you look at Singapore next door, we have been in this field for a while. So we have built global companies as well who used to supply to the semiconductor multinational. They are now themselves a global player. So and therefore the talent pool is there, which is now a global shortage of talent pool. So a lot of talents are looking at it. And lastly, just so that we can have a more interactive session, is the infrastructure. The electricity is important. Of course, like you said, it consumes a lot of that, water as well, and ensuring that the logistics of it, because most of this, when you look at the supply chain, they're not talking about, of course, it's physical supply chain. They're not talking about ships, but they're talking about air freight, right? They're talking about airports, etc. So you need to look at the future, where it's heading. I think we can have an open discussion on this because everyone has a different view, different perspective of this, because all countries now, if you look at incentives that are coming in from India, there's a major incentives looking at Japan, of course Taiwan being a major player, even in Europe. So every country now are looking. I mean, the US, as you mentioned about the CHIPS Act, even, and various other countries also have regulations and guidelines, but they are trying to rebuild this industry or building the industry in the kind of 4 strategic reasons. And technology is going to be key. And I think if you look at where we are today, you mentioned about that growth, Professor, but I think that growth is going to be more than that because adoption of the technology with advancement of AI, advancement of various other new technologies, we talk about EV, etc. The numbers are really perplexing if you look at this. But the issue is, we think this year is going to be a good year for it's another tech upcycle, we think. And therefore, investment is going to be key, trade is going to be key, and we hope that this semiconductor supply chain will then benefit in terms of country's economy and growth as well. So thank you.
Thank you so much. Wait, let me take this out of my ear. Thank you so much. No, don't sit down. I need you to stay up here. No, you stay up here too. We have about a little over 7 minutes, which is fantastic, and I apologize for the rush, but we have the video that we need to account for. I have 2 questions already. There is a microphone which you have to use for the TV. Fantastic. If you could introduce yourself and ask, I'm going to take both questions and let my speakers respond.
Duncan Wood from the Wilson Center. Thank you very much. Excellent presentations. I just wanted to say that what brings all of this together in my mind is essentially the resilience of the supply chain globally. All these factors impact upon that. And having greater diversification is the key thing here. So it's wonderful to learn about Malaysia. It's also intriguing to see what's happening right now with regards to Mexico being part of sort of the US supply chain. And getting more of the supply chain into more countries seems to be the key thing here. In that way, you seem to be able to overcome so many of these different elements, including the workforce, including environmental stress and strain. I'd just love to hear your comments on that.
Great. We're going to take both questions first. Oh.
Thank you for the presentation, Mikey from South Africa, computer scientist. With the recent announcement from OpenAI with the need for chip power, obviously with the growth of artificial intelligence, do you see a potential risk on the move from the region as the key central supplier of chips? And I guess it's building on the question there. Do you anticipate in years to come the risk to shift to other regions as key producers of chips? Thank you.
Okay, those are some fantastic questions.
Yeah.
Why don't you want to start?
I'll start and the professor can be more detailed about it. So yes, I think for your question, for me, I've been looking at it objectively. What we need to know is where the technology is going to go, right? And we also need to understand the importance of the supply chain. And like it or not, if I was a company, I mean, I was in the private sector before, you do not want to be in one region. That is the truth. I mean, yes, of course, selfishly, we want it all to be in Asia. Like I said, it's already 90% of semiconductor is in Asia for now. But going forward, given the size of the pie that is growing, it is okay to share with it, because at the end of the day, I think there are comparative advantage of each country, and there are experience in companies that lies in the talent and the what they call it, infrastructure. So you need, for example, most of these companies, the multinational companies especially, they have their RE100 targets as well. So they will need to look at nations that are able to supply them that green power, that renewable energy. And you cannot get to the end game if you just focus in one or two regions. And I think it's good politically as well, geopolitics-wise, and for the security and resilience supply chain to spread it out. And you are seeing, I mean, there are companies in our region already working in the States, supplying, especially on the assembly and test, the back end, the equipment are actually coming from Asia into Europe. So, of course, the wafer fab, the IC design stuff are a bit more advanced, technical, in terms of ability to do that. But I think at the end of the day, it's important to start not just focusing in one region. And we are definitely, we are ourselves, our companies in our region are also diversifying out of the region. And that's what we see. Yeah.
Fantastic. Yes, go right ahead.
Okay, I can just add to that. So I think if you think about semiconductors in general, it's a pretty steady, it used to be a pretty steady supply and steady need. It's truly going to hit what we call exponential with the demands. I mean, and this is simple equations and math will tell you that kind of, we are at that neck where we are going to see that. So it has to be diversified. There's no way we can, do the same old to keep up with the demand. The two other important things is, the two things that help us diversify is connectivity and policies. Connectivity is already there. I mean, couldn't be more connected world, right? How about the policies? So I think how I would phrase this is, it really depends on our global leaders to kind of lay this out in a way that can be practiced today and also set the foundation of the future, because we are going to only leave a bigger mess if we don't act now. So it's kind of an important thing to keep in mind that that is laid out by the policies as well. Yeah,
Fantastic. I would love to, okay, we'll take one more question because he's been patiently in the window. And then this will be the last question. And if you have any additional questions, you'll be able to ask our speakers afterwards. Yes, go right ahead, sir.
Okay, it's okay. Hear me? Oh yeah, I know the semiconductor chains for the AI is very, very important. But for AI, the main another consumption is the power, the electricity, but costs a lot of electricity to help to improve the AI. So before US have Intel in China, in our city, but now the transfer, is it, I think my suggestion, this semiconductor producer should connect it with the big electricity, the green power. Is it possible?
Go ahead. So I think that is one of the mission of sustainability. Now, one of the things that every industry, or at least some of them, are very ambitious, and I think that's a great sign that people are ambitious in setting this target. But the sustainability is being folded into any discussion with semiconductors. So I think this problem, again, if we don't lose focus on the sustainability, it will get solved, because remember that the energy production itself is also dependent on semiconductors. So it's a little complicated to understand which one will win at the end, and hopefully there is a net positive. But at this point, every industry has a sustainability on their roadmap, and that should be, that will kind of solve some of these issues.
I'm sorry, I'm going to have to stop you. So I just wanted to say thank you very much. I think what this panel showed me, at least, is the critical importance of having a multi-stakeholder approach to this, with government, with industry, with academia, with groups like the WEF. And so, because otherwise you will miss out on the complexity of resolving where semiconductors ought to land and what are some of the consequences if they are placed in different locations, if we don't join up all of the elements of this. And so I think it's been really fascinating. Apologize that it's so short, but at least a sort of nice introduction to the complicated world of semiconductors today. And I'd really like to have you all thank me in acknowledging our speakers, especially the wonderful Minister of Trade from Malaysia and our fantastic academic out of Stanford University. So thank you guys both so much.
Thank you.